All right. Okay, so today, we're going to be doing questions from the spring 2019 final exam. Actually, I'm going to be doing a whole bunch of different problems. One of them is, the first one is from the spring 2019 final. This is question 2. I'm doing partial fractions questions. Okay, so the first thing that we have is we're going to need to find the integral of 5x squared plus 12 all over x cubed plus 4x dx. Okay, so whenever I see this kind of an equation in the denominator, I need to start thinking about how am I going to be able to make this happen. It's really windy outside, sorry. Okay, so how am I going to make this happen? So the first thing I need to do is I'm going to write this down just as an equation off to the side. So 5x squared plus 12 all over. And I'm going to write this as a factored equation. I've got an x cubed and an x here, so I'm going to factor out an x. So I have an x squared plus 4. Now, I can't factor this part out, the x squared plus 4, any more than it is right now, because this is an unfactorable quadratic. If you're not sure, like people are tempted to, factor this out into, x squared, x plus 2 times x minus 2. I encourage you to FOIL that out. You'll find that's x squared minus 4. Okay, or people think it's x plus 2 quantity squared. If you do that, please factor that out, like FOIL that out to check. Always, when you look at these things, FOIL them out when you're factoring things, just to make sure that you're not factoring things incorrectly. Because there's nothing like going through the whole process of partial fractions and then finding out that really it was just an algebra mistake at the beginning. Okay, so now I have x and I have x squared plus 4. X squared plus 4 we just said was an unfactorable quadratic. So the form I'm going to use is I'm going to take my regular variable a and put it over x plus, now I've got x squared plus 4. I need to put that over bx plus c, put that under, sorry, x squared plus 4. Okay, so I've got x squared plus 4. I've got this in the form of bx plus c. Okay, so that's basically, I'm going down 1 power from what I have here. This is the form that I need to do. Okay, my whole goal on this is to be able to solve for a, b, and c. So now what I'm going to do is I'm going to multiply both sides by x times x squared plus 4. Okay, so that it'll cancel out at the bottom. So what I'm going to be left with here is 5x squared plus 12 equals a times the x's are going to cancel, so x squared plus 4. Plus, make sure you put parentheses around the bx plus c. Now this cancels with that, and I'm left with that times x. Okay, so now the first thing that I'm going to do is I need to solve for a, b, and c, but I have some low-hanging fruit. So this x here, this is where the root of that, the solution for this is where x is equal to 0. So I'm going to be able to actually solve for that, use that x equals 0, plug that in for all of my x's, and then be able to solve for what's left over, what letter is left over. So when I do that, I've got 5 times 0 squared plus 12 equals a times 0 squared plus 4 plus b times 0 plus c times 0. So this whole term here is going to be canceled out to 0. And I've got a times 4 equals 12. Divide both sides by 4, and I get a equals 3. I'm going to put a little box around it so that when people are grading your exam, they can see that you had your A, B's, and C's really easily. Okay, so now what we're going to do is, I have a equals 3. What I'm going to do is I'm going to plug that back in. So I've got 5x squared plus 12 equals 3, x squared plus 4 plus bx plus c times x. Okay, so my goal now is to be able to find b and c. Okay, but I've got this 3 here, so I'm going to distribute this 3. Now, what I need to do at this point, because I was dealing with an unfactorable quadratic, I now have to use the other method, which is I can't use this. There's nothing I can substitute for x because x is a solution for this is an imaginary solution. Okay, so what I have to do is line up the corresponding coefficients and be able to solve using multiple equations. But first, I'm going to factor both of these here. I'm going to distribute both of these here. So I've got 3x squared plus 12 plus, this is bx times x, so bx squared plus c times x. Okay. Now what I'm going to do is I'm going to group x squared terms. So I've got x squared times, this is 3 plus b, right, plus x times c. There's only one x term. Plus, and I only have one constant term, which is 12. I'm putting them all in parentheses just to kind of illustrate what that looks like. So here I've got 5x squared plus 12. Now, let's start grouping things by coefficients, okay? So what I have is 5 and 3 plus b are both coefficients of x squared. So I'm going to say 5 equals 3 plus b. Because remember, what we're doing here, this is equal to this. Okay, so we're basically, we found the common denominator, brought things together, and we have it looking like this. We're doing the backwards path to that. We want to be able to break things apart into their individual pieces. So 5 equals 3 plus b. I'm going to put a little dividing line. I've got a 0x term, so I've got 0 equals coefficient of x over here, which is c. And then I have 12 equals 12. This is a good cross-check. It's good that our constant terms are equal to each other. It means that we've multiplied things through and that our a was correct. Okay, so c equals 0, so I'm going to put a little box around that. I can solve for b right here. I get 2 equals b. I'm going to put a little box around that. I'm going to put boxes around your answers so that people can see when the graders go to grade these things, people can see that you know what your terms are. Also, if you get your A, B's, and C's wrong, we can give you partial credit when we go to grade it. Okay, so now this was just to find things back up to here so that I can then substitute it in right when I go to integrate. So let's remember where we were. So this is 5x squared plus 12, x times x squared plus 4, dx is equal to, right, we're going to use our a was equal to 3, so this is 3 over x dx plus bx plus c. Our b is equal to 2, 2x plus 0 all over, oops, sorry, like that, x squared plus 4 dx. Okay, so that was the whole point about partial fractions, was to take this bigger thing here and break it down into individual parts so that then I can integrate it. Okay, so now in both of these cases, let's think about how we're going to do this. So this is 1 over x. The integral of 1 over x is the natural log. 3 is just our coefficient term, so it becomes 3 natural log. Make sure you specify, because you're taking the natural log of this function. We want the absolute value around that x. Plus, let's talk about this one now. So I've got x squared plus 4, and in the numerator, I have 2 times x. Well, x is a derivative of x squared, so let's think about u substitution. So u equals x squared plus 4. My derivative, du, equals 2x dx. Look, I've got a 2x dx right there, so I don't even really have to do any, I don't have to divide by 2 because I have the 2 there already. So let's substitute this in. So I've got 1 over u, right, because that was our substitution, times du, which makes it the natural log of u, right, when I go to integrate this. And let's add our plus c in so we don't forget to do that at the end, because this is an indefinite integral. So let's substitute our u back into this spot right here, and then we'll write our full answer out. So 3 natural log of the absolute value of x plus the natural log of our u, which was x squared plus 4. And then don't forget your plus c because it's an indefinite integral. And that's our step through. Okay, so how we take this integral,